Alright, this is my demo for milestone 2 for CSC588. I'm opening up the code here and I'm going to try to get through this as quickly as I can in 10 minutes. So going over this really quickly, this is the game thread. It'll spawn the audio thread. Audio thread will spawn the file thread and then spin while waiting for commands to execute, and they'll sleep for a millisecond. File thread will spin waiting for file thread load commands to execute, and then it'll load the file, it'll load the data, send file load done command back to the audio thread, and then wait a millisecond. Going through some of these features really quickly. So X-Audio2 voices, attributes, loading waves, multiple instancing. I create sound objects with volume, pan, pitch attributes here. Sound, when called from the sound manager, it'll send the audio to send to the audio thread a command to create the sound command there, which will create the A sound object on the audio side. It also has volume, pan, pitch. It has a pointer to the voice. Voice owns X-Audio2 source voice, the voice callback, the wave data pointer, which doesn't own it references. Wave data owns the reference to the data, and then there's managers for all of this. Upon ending of a stream in the X-Audio2, on stream end for the voice callback, we'll call next buffer on the sound. This will give you seamless stitching in the Seinfeld example. What else? So stitching I'll demonstrate, multiple instancing I'll demonstrate in the demo. Priority table I have here. It's an array of priority nodes. A priority node holds the sound pointer, the handle ID, priority, time playing. It's of size 6. On adding and removing, I sort the table, so when I'm adding a new sound, I only have to check against the last entry in the table whether or not the current sound gets added or not. And then I'll add it, I'll stop the sound that's already in there if it's active, I'll set the entry in the table, and then I'll sort it again. Same thing in remove, I'll just remove it, reset it, and sort the table. Game user callbacks I'll go over in the demo. Asynchronous file loading I'll go over in the demo as well. Audio management, I have the handles in the handle manager. I showed the wave data buffers, the voices, and then I'll show that it doesn't leak memory when I'm done. So now I'll just go ahead and start playing these demos, and I'll talk about some more things as it's playing. So starting this up, it's spinning here. Let me switch to the output, and I'll start by pressing 1, demo 1. So you saw that the spaceship stopped spinning for a moment there while the files were loading. I could have done this asynchronously over here and the spaceship would have kept on spinning, but I left it blocking and the spaceship paused to show that I'm using the file slow library and all of this. So right now it's going through the demo features, same in milestone 1. I have it set so that at the play and stop of every sound, it'll print the priority table with whatever its current values are. So right now, for example, it just started playing song A, song B, and after playing song B, it has 2 entries in the priority table. Song A prints, it's playing for 5 and 8 seconds. So the way I do time events here is that my sound class has a linked list of time event nodes, and I can add timer events to the sound object. And then in Sound Manager's update loop, it'll not only check for any user callbacks that it has to execute, but it also updates every sound object, and in that sound object update, it'll check every time event that hasn't been executed, and if the time passed, then I'll execute it. Here, you'll see the multiple instancing in a second. Did multiple instancing so you could hear them overlapping. Now I'll go ahead and talk about and do the demo 2, the Seinfeld. So it loads all the files, creates a Seinfeld sound object, plays it, and then I have the timer event commands that every 10 seconds it'll pan to the right, pan to the left, pan back center. As the next buffer is being attached, it'll print it over here. So yeah, just thinking if there's anything else to talk about in the meantime. Coming up, I'll demonstrate the async loading for demo 3. So now the last buffer was attached, it ended, the priority table was cleared, and the audio stopped. Starting demo 3, I loaded Electro and Alert. I first load them, and then I initiate Electro sound, I play it. After that's done, I initialize the Beethoven sound without creating it on the audio side. I create the file load callback, and then I start loading Beethoven async so that when it's done loading, it'll do all these actions. It'll stop Electro, create the Beethoven, and play Beethoven. So right here, Beethoven was done loading. It printed that right here too, and then it printed that everything was stopped. Electro was stopped, it attached Beethoven, it started playing Beethoven, and the volume was set to 50%. So the async loading was happening in the background while this was spinning. And my file load callback, I essentially created it and passed it in, and my file load callback holds a linked list of command pointers so that I can pass in whatever commands I want, and that way I can customize what I do in my file load callback. So now after 60 seconds, the time event that I added to stop Beethoven after 60 seconds was called. So demo 3 is done. Moving on to demo 4. This demonstrates the user callbacks. So I'll again do blocking load, create the user callbacks, which when executed, it'll print the handle ID, the pan value, the duration that the sound was playing for, and I pass this into the sound creation, and then I'll play the first 3 and then play the 4th after 3.5 seconds. So I'll start that by pressing 4. So as you can see over here, like the first 3 were added, this one ended and it printed those values, and then when it stopped this one, it printed out the sound ended again, and this one stopped, it printed out the sound ended again, and then you can see what's left in the priority table after it ended. The sound ended as I think for this, and then this sound ended is for Moon Patrol. There's nothing in here, and it says that Moon Patrol stopped. So that's the user callbacks working upon, and if there's time at the end, I'll show where that is in the code. Now demo 5 demonstrates the priority table, so pressing 5 loads this, and then I have all the sounds here where I'm setting the priority values. I'm adding the first 3 right away, adding the next ones every second increment, and then I stop all of them in the active table at time 13. So that was all the demos. I'll talk about the priority table, but right now I'll just press Q to exit out, and then I'll press escape to exit out cleanly, and you can see that memory tracking passed and everything exited cleanly. Now here in what's it called? For demo 5, this is where the first 3 coma sounds were added. This is what the priority table looked like when the next one was added, when the next one, and you can see that every time I'm adding them, so adding 50 and 75, it's sorted, and it's sorted by time playing also. So that next one is added, the next one is removed, it's done, because this table is full, when the next one is going to be added, first it has to remove the last one, making it inactive, then it adds the next one. This happens again, and then as sounds like keep dropping off, this is where we'll be. And then as sounds stop playing, it'll slowly remove them one by one. How am I doing on time? Okay. So I'll remove them one by one. It'll have none, and then once it stopped playing all of them, it'll show an empty priority table and all of them are inactive. And then yeah, here's the handle, and it shows the priority duration. It has all that information as well too. So really quick, I guess, I just want to cover quickly the user callback. I have it here where on end it'll do this. In the sound, I pass it in and I send that to the asound object as well. And what I do in the asound is in the next buffer, pretty much when the stream is ended, if there's no next buffer, then if there is a user callback, it'll call the end for that. If not, it'll just use a generic sound end callback and send that over to the game thread to be executed. Otherwise, it'll do the user callback, which it'll do all of this and stop the sound. So I'm almost out of time. I hope I covered all the features thoroughly, but this is my milestone 2. I implemented all the features as best as I can, And I thank you for watching.